In this training lesson, we will compare and contrast the differences between the SQL object and the custom SQL object in Visual App Builder Pro. In a previous lesson, we created a sales order dialog box in order to be able to enter a sales order number and display the line items for that sales order. And in our last iteration of that, once we entered the sales order number, we were doing a bulk command to get down all of the items for that particular sales order, and then reading the first record out of the flat file and updating the list, which is our list of sales order items. We're going to make a slight change to this, kind of illustrate the differences between the SQL object and the custom SQL object. Let's go ahead and change the list itself. So instead of displaying the item ID, which is the barcode value, we're going to display the item description. And to do that, we're going to need to import the table that has the item description in it. If you're not familiar with the import data, you need to watch that training lesson. So it's the catalog table that contains the item description information. We'll go ahead and import that. And now in our list, we'll display out of the catalog the actual item. So that's more like an item name rather than a barcode, so make it easier to identify what it is in our list. Actually, we could have both pieces of information or as many columns as you need in a list control, but for the purposes of illustrating the differences between the SQL and the custom SQL, this will work just fine. Let's change the name of this also to item. So now what we'll have to do when we populate this list is select from the catalog with our SQL object. So now once we do the bulk and we read the first record, before we update the list, we're going to have to select from the catalog and then update the list. So this is our SQL object. All the names of the tables, SQL tables that we've imported into our project, will appear in the drop-down list, along with all of your standard SQL verbs or actions, commands that you can perform, including some rather exotic things about beginning a transaction and committing transactions and rolling back transactions. These are all supported by ODBC, and therefore we support them here in the Visual App Builder environment. Here we're simply going to select, and this is our clause builder. So typically we're building where clauses, although if you're doing an update statement, you would be setting values for your existing columns. Here we'll say where the item index is equal to so.dat item index. So this will look up in our catalog the description. Now when we update the list, one of the things that it will be updating is the catalog or the item column instead of taking the item ID directly out of the sales order, the so.dat. And so after we read the next record, we'll do the same thing again. We'll select the catalog before updating the list again. So now let's go ahead and run this quickly so we can see the effect that that has. You'll see now you get an item description instead of the item barcode value in our list. Now this is fine if you've got a small list. It becomes a problem if you have a large list with more than 100 entries in it or so, and in business type of applications you can certainly run into that sort of situation. So a more efficient way of doing this is to actually use the power of SQL. We've created a constant, and this is how we go about starting to create a custom SQL object. Is we start with the SQL statement itself. I've gone ahead and typed one in here where we select from the two columns, the item description and the quantity, from the sales order table where it's interjoined on the catalog on the sales order item index equal to the catalog item index, where the sales order is equal to the tilde character. Now there's a couple of things going on here. One is that we're going to be getting back two columns directly from this SQL statement as opposed to doing the manual steps that we just illustrated with a regular SQL statement. The other is that we're going to have a substitution take place here with the tilde character. So now in order to get ready to run this, we're going to have to create a couple of files. One is a substitution file where we'll copy a value in to be substituted at runtime for that tilde character. We'll make this a fixed length. We don't need a carriage return. And the sales order number will be the only value that we're substituting for. You can have an unlimited number of values that you substitute into your custom SQL statement at runtime. In this particular one, we'll just do the one. Then you also need to define a file layout for the columns that you're going to get back from your custom SQL statement. We use a lowercase c just so that we know that this is a custom. And the type is mandatory. Custom SQL table is the type that you need to specify. We need to specify the data source that we're working with so that at runtime we know which data source to access. And now we'll just add the columns. First is the item, which is text 20, and the second is the quantity, which is a long integer value. And then last but not least, we're going to make a copy of that table. So we'll do a copy file. We'll edit this because we're going to use the bulk option within this custom SQL statement to get down the whole record set at one time. This is very similar to the standard SQL object and using the bulk verb there so that you get an entire file down at one time. And it's the same convention where we'll use the name of the SQL table or the custom SQL table in this instance and append a .dat to the end of that to form the name of the flat file that it creates from the record set. And these are always fixed length without the carriage return line feed. And so now we can reference the data set that we get down from the COM manager by using this reference to cso.dat. So to finish this off, what we need to do is just come here to to create a new object. And this is going to be our custom SQL object. And here we specify a constant that contains our SQL statement, that was there, and our substitution file, which is this one. So any place where a tilde character appears, and they're in order. So if you have two tilde characters, then we will read them sequentially starting at the beginning of the substitution file to make those runtime substitutions. And then our results will go to our only custom SQL table that we have defined here, and we will check the button for bulk. Now once we get the cso.dat created, we'll go ahead and just populate the list. So this will definitely shorten the number of objects that we have in this procedure, and it'll also make the response time much faster because all of the cross-referencing between the item index and the item name will occur within your database server. So it'll be much less work for to take place on your handheld device or on your PC application, your Visual App Builder project. So from the OK, we'll go ahead and do the bulk command, our custom SQL command, and then we'll populate the list like so. So the last thing we needed to do is change our list. So instead of referencing these values, they're referencing our new values, our cso.dat. So there's our item, and here's our quantity. Now we should be ready to go. And this will provide you with the fastest possible response time, much better performance that you would get from manually doing the cross-reference, manually selecting each one of the item descriptions. Or as you can imagine, if you needed to display customer names or vendor names, you would want to use the same sort of technique. Let's go ahead and run this. But there's one more thing we need to do here before this will work correctly, and that's to copy the sales order value into our substitution file so that at runtime we know what sales order to go get. This has to do with our tilde character. Right, and so now our so.sub will be populated with the 18 that we're typing in there for the sales order number, so that our SQL command will return something. Let's go ahead and run that again. As you can see, the results of using the custom SQL statement are the same as having done it manually with the SQL statements, but your performance is several magnitudes greater, and the number of objects that you need to have within each one of your procedures is greatly reduced. Another feature that's available within both the standard SQL commands, SQL object, and the custom SQL object is where clause elimination. If in any of your where clauses the value at runtime that you're comparing to is blank, then that where clause will automatically be dropped from your SQL statement. This comes in very handy if you are trying to filter some data, filter some records out of your database for displaying in a list, and we'll go into some more detail on that later.